Hey guys, I'll show you how to make a 3D minimap in Unity using Unity's Shadergraph and terrain system. So the starting point for our tutorial will be a working character controller. Then we'll need either an in progress or the final terrain geography. We don't want to change this too much. If you can change, no issues, but this will need to be baked again and again. And then we need the resources that need to be shown on the minimap. So these are the steps summarized. We'll first bake the terrain to a mesh, and then we'll generate the tracked resources which we need to show on the maps data. Then we'll make the shader for the map, and then we'll finally implement the final scripts. I'm using Unity's Starter Assets third-person character controller for the character controller. It is very useful in general for quick prototyping, and in this case as well, it's very flexible. So this is what the scene currently looks like. We have our character controller. We can jump and move and walk, and these red colored springs are our large resources, and then we have our blue springs which are our small resources. Two types of resources that we'll show on the map. And yeah, let's get started. So first we'll need to export the terrain data to a usable format. So if we click on the terrain, we can go to the terrain settings tab, and there we have the option to export raw. We'll leave the settings as default, and then we'll click export. Once it's exported, you can see it will be wherever you have chosen to save it, and something like terrain1.raw. And this is the file we need to use. But if we try to open it directly in Krita, it won't work because it doesn't know what it needs to read, the correct dimensions and such, and it's not going to work basically. So to get it working, what we'll do is we'll click on the file and then rename it to R16, and this will basically change its format to what Krita understands easily. I'm pretty sure Photoshop might have similar steps as well, but I'll follow along with Krita. Then we'll click on this and we'll open it up, and now we can basically guess the dimensions of the file and it will guess correctly. Otherwise we can check the Unity inspector to know the dimensions as well. Here we have the Heightmap resolution, and now we can click on OK to generate it. Alright, so this looks like our Heightmap, which is very nice. We'll need to export it. We'll export it to something convenient for us. We'll export it to PNG format and save. Now that our Heightmap has been exported, we'll switch to Blender and we'll delete the default cube as usual, and we'll delete everything else as well. Add the default plane, and then we'll switch to our modifier tab and click on displace. So firstly, let's get the mid-level. And now we click on this to create a new texture, and we'll call it this map. And now let's switch to the textures tab, and then we'll click on open to open the folders, and then we'll open the PNG file. Now we have opened the PNG file. We can switch to our we'll move it to 0. So the reason why it is not showing up is because there are only 4 total vertices. So what we'll need to do is we'll need to add the multi-resolution modifier. We'll drag it above, and then we'll start subdividing, but not like subdivide properly, just simple subdivide, and that should basically start adding a lot of detail for us. We'll keep a count on the verts over here, and we'll need an approximately solid amount for that. So what we'll do is we'll basically multiply, and we get this 262 like 1000 watts. So simple, it's 66 263, and yeah, that's our number. So that's well and done, but as you can see, the height is not correct. So to correct that, what we'll need to do is we'll shift to the textures tab, and then instead of sRG, we will change it to raw, and that should basically give us the correct height. Now let's compare it to our Unity terrain. So if we switch to the top view and switch to the top view here as well, you can see that it's not matching. And for that, we need to invert the y-axis in our case. So I'll press the end button to bring out this sidebar, and then I'll click type -1, and now it should match. Let's also compare the height. As you can see, it's very well matched. So this looks pretty good for our mini map, but there's a 250,000 vertices over here. So yeah, it works fine in Blender, but this is not good for the final mini map. So what we'll do is we'll basically first of all go to shaders tab. We'll use the default material. We'll rename it to something like map minimap mat. Then we'll switch over to the shading tab and press dot to focus on it. So I'll basically bake all this normal information to a normal texture. So we'll shift A, then click image texture. We'll add image texture, and then we'll add the vector nodes over here by pressing Ctrl T. That will add both of these, and now we will generate a image texture file. So we can go with this, but I think we can just generate a higher res here, and then we'll basically downsample it in Unity itself. So we'll call it minimap normal. Let's just add a UV grid, click OK. We'll check it out, and yeah, looks fine. So shift to principled BSDF and then click on minimap normal. Now I'll switch to this tab, render properties, and make sure you are in cycles, not in EV. Then we'll click on the bake section, and then we have different options over here, and what we'll choose is normal. Okay, and here we have option to click bake from multi-res. So if we do that, what this will do is it will bake it from the multi-resolution modifier. And now we can check out what level we want. So if we click on wireframe, we can see there's nothing. But if we disable optimal display, we can see all this detail. And yeah, it looks pretty nice. We can click on Alt Z to disable see-through, because if we have see-through, we can see it like twice. So we'll disable see-through, so we can only see the side which we are looking at, not the whole thing, with Alt Z. Okay, so yeah, this is good resolution, but we need it to be lower. So we will decrease it slowly. Yeah, this is in the too less zone, and we have 1000 watts, which is too less. 6 is like 4000, okay, but not that much. 7 is very nice. 7 has all the major shapes without necessarily going into the detail zone. So we can keep it at 7. You can go lower if you want, but I think I'll keep it at 7. Okay, so yeah, and let's just switch back to solid ones. Yeah, even this is actually usable without a normal map, but we'll bake one. Yeah, I think I'll go with 7 and switch to the sections, and now we'll click bake. Oh, sorry. And this error is caused by us not applying the displace modifier, because this only expects a multi-res modifier. So we'll click apply. That will apply our displace modifier. now we can bake it. So let's bake, and yeah, let's have a look at it. So as you can see, it looks like a very nice normal map, but it's not normal. uh, like, no pun intended, actually pun intended. So the reason for that is, in our multi-res modifier we have UV smoothing enabled. We need to click none, and then we'll need to bake it once again, and with that it should be, yeah, should be nice and square. Now let's have a look what this normal map looks like. So we'll switch to material preview, and as you can see, yeah, it's like okayish looking, but we can make it look better. So we'll add a normal, no, not that one, normal map. We'll click, drag this, and then we'll drag this into here. And as you can see, yeah, it looks pretty nice. Works with this as well. So yeah, let's just check the difference. Yep. Oh, sorry. Significant difference. So we'll save both this mesh as well as this file. So we'll go over here and we'll create a new folder. No, we don't need to do that. We'll call this minimap underscore terrain. I'll save that. For convenience sake, we'll also save it in the same folder, minimap normal. Yeah, this is we can give it a raw value. Save as image. Now upon switching to Unity, it will start importing the mesh and the map. So let's check it out. We have our minimap terrain, and yeah, it's there very well. We can just drag it to check it out. We'll also create a material for it right now. Minimap material. We'll assign the material to it as well. Or rather, what we'll do is we'll assign it in the material override section and apply, and that should basically do it over here as well. Now we'll basically add the normal map to this section, and oh yeah, it looks pretty nice. We'll fix it. Yeah, looks pretty good. So now that we have the mesh fully baked and ready, what we need to decide is what we will use as our scale ratio. So that basically decides how much movement in the real world will be represented in this minimap world, and we need to get that fixed as soon as possible. So we know that our mesh is 1000, sorry, our terrain is 1000 into 1000 units, and currently if we check in Blender, if we press N, we can see that our this baked mesh dimensions are 2 meter by 2 meter and into 0.559. So that is that we can work with that, but I think I would like to simplify this even further. So what we'll consider is, so what I would like to do over here is we'll basically add a small capsule collider over here, capsule mesh over here, and we'd like to basically think what we'd like its size to be on the screen. So let's just say it's over here. Now we decrease its size to different levels, and yeah, I think I like 0.1 as well, but we can go even lower, something like 0.5 0.5 can also work for a minimap if we basically have something like a full screen. This as a representation of the player can work as well. So we'll say 0.05. So that's 20 times smaller than our actual player size. So one is the full, and if we divide by 20, we'll get our player size. So that's the proportion we need to shrink the world map to this map. So if we do that, what we'll have is 1000 divided by 20. So that should lead us to 50 by 50 size for this map. So what we'll do is we'll just simply I'll just simply change the dimension over here to 50, and we can see it led to a multiplier of 25. We'll change this multiplier to minus 25 and this to 25, and as you can see it's adjusted. Now save and change to Unity. It has changed it, and yeah, we have our map over here. Alright, so the mini map has been changed to a scale that we would like to see. Let's just drop our player to nice position. Also, as you can see, it's low res, but we can also increase the normal map modifier to make it stronger. So let's increase it to 2. That one we were not able to see everything, so let's keep it at 2. All right. Another thing that we didn't do earlier was the fact that if we check out our terrain, it's centered on the lower left. That's its pivot, whereas our main terrain is not like that. It's in the center, so we'll need to change that as well. Okay, so let's find our map, and as we can see, its origin was over there. So what we'll simply do is we'll just click on the vertex over here. We'll click on press Shift S and cursor to select it, and that will move our cursor to over there, and we can tab out of it, and then we can click set origin to 3D cursor. Now origin has moved to that location, and we can basically move it over here, and yep, now it's centered correctly. Let's see it update, and yep, it's done it correctly. It's also given it a 180-degree spin. I don't know why, but as you can see now, it's a very nice replica of our actual terrain level. Okay, so I've made 2 different screen captures of this red and blue spring, and then I have basically cleaned up the background in Krita. Now if any imported textures are not showing up with transparency, it's probably because alpha's transparency is not ticked. You can click apply and it should be transparent. Now I'll create a prefab of each of these and store it. Okay, so now it's time to make some scripts. So firstly, what we'll do is we'll attach a script to our minimap, which we'll call Minimap Script. Now we'll open this up. Here first we'll declare a type of enum that we can use across our scripts. So we'll go public enum icon type, and then we'll say let's go with red string, and small blue string. Save it. Okay, so now we need to add a new script to all the resources present in the world. So like this and this. So what we'll do is we'll basically go to collectible large. I think I'll like to rename this as well. Collectible large red, collectible red large, and collectible blue. So this is our original prefab, and this is a variant of that original, so we can just add it to the blue and should basically follow it here. So what we'll create is Minimap icon source. Open it up, and now first of all what we'll do is add this icon type. So public icon Minimap icon source. Not this one. Yeah, icon type. So we'll have to go to, what we'll do is we'll just cut it and make it a separate class basically, so we can now access it easily. And yeah, small, and that should do it. So it's added, so we can select that this is a small blue spring and save it. Then go back to prefab and check large variant and set it to red. So save this one as well and just double check small blue, large, and let's go back. So all our resources should have the script now. Now in Minimap script, what we'll do is we'll have an array of Minimap source icon sources. I'll find it. No, find object of type, find objects of type. That should basically find the icon sources. Now we'll add a list of prefab that we'll use to basically populate the minimap. Now run a loop that will go through all the objects. Now we'll go through icon sources one by one. Dot type. This should give us the icon type. We'll store this in an int. And then use it to instantiate a prefab. Now the position of the prefabs needs to be determined. So to calculate the position, we'll need to basically have a ratio. So what we'll do is we will have a public vector3 full map dimensions. Then we'll have Minimap dimensions, and then we'll have a internal value which we'll call multiplier rather. map multiplier. So since we need to minify most real world or rather non-mini version, the full scale data to a mini scale, what we'll do is we'll basically minimap divide by full map dimensions. But this is not how it will work exactly. So we'll have to do it according to vector 3. So what we'll do is map multiplier equals to new vector 3. Yeah, 3 times. Now we'll do dot x, dot x, dot y, dot y, dot z, dot z. And that should basically make it so that if we are not offsetting anything, it should basically generate the new position. So we'll have to make a multiplication function. So we'll do it over here. Public So now we can use this to basically generate a position. Yeah, so what we'll do is we'll have multi-vector and we'll basically have our icon sources I dot transform dot position comma map multiplier. And now let's keep quaternion dot today, and that should do it. So now let's save and switch to Unity. Okay, let's check our sources. We don't have any sources. Let's check our prefabs. We don't have any prefabs. Alright, so we'll need 2 prefabs. Which is our order. We have large and small. Okay, so red is large, and then we have blue is small. Okay, now we need to set our sources, so I'll lock this and I'll basically select all, drag, select all, drag. This should basically have our sources section done. Control S to save. Okay, so now let's put our dimensions. We have 1000, 1000 and 600, and we have I think 50, 50 and 50 into 0.6, 30, and save and play. Okay, as you can see, at the base of the hill there are 2 generated meshes, and we have 2 at this point as well. And yeah, I think it's fairly well done. You can see this is red one, and I think if we check it out, we have a red one over here as well, just before the small peak mountain. Yep. Okay, I think however, if we try to do certain things, it might cause a bit of an issue, because if we move it, it doesn't move along. So we'll need to basically keep it updating as well. So currently the icons themselves don't have any behavior, so we'll do that first. So we'll go to Blue Spring 2D, and I think this should be done using a common class, common prefab that has two prefab variants rather than this method, but just do it right now. Minimap icon behavior. Okay, so first of all, we'll add a class called public void initialize icon. So here we'll have a camera. I think we can just keep it transform camera. Okay, now we follow that with the Minimap icon source. So we'll call it source here, and Minimap icon source. So we'll assign both of this. Save and switch over to Minimap script. Now we'll call this. We'll need to save it, so we'll do a var temp dot get component. We can actually change a bit, but that might cause an issue. We can, instead of doing this, we can have a Minimap icon source, but we'll need to drag the prefabs once again. So let's just do that. We don't need to get component. We can just call icon behavior. We'll store this as well. We need to pass the camera, so we'll basically get the camera over here. Camera.main is just a find component of type. So, or I think find component by tag. So if it doesn't return any results, null reference on this line, you can use alternate methods. Dot transform, and we can pass camera transform, and we can also pass Yep. This should allow us to make the actual icon behave at a um, particular way. So what we'll do is we will have the icon always look at the camera. So we can have a custom scale. That's it, we don't really need it. Now switching over to Minimap, let's write the update script for updating the location each frame. So to do that, firstly we'll need to store all the instantiated variables which we haven't done till now. So we'll create a list of Minimap icon behavior, instantiated icons. Basically we'll add icons whenever this loop finishes. Now we can basically move to the update loop. If it feels like this is chugging too much, you can always switch it to a separate coroutine to update it less frequently. Yeah, now we have to reorganize a little bit. So collapse these, create something called Minimap parent. We will reset the transform firstly, and then we'll parent both of these to this. So now if we can basically have it so that all the created icons are parented to Minimap parent. We'll change that over here. So we'll go transform dot parent, and we'll basically assign all the Minimap icons to its parent. Next, we'll basically make the PlayerIcon script. So let's just disable the capsule collider for now. Focus on the yep. So we'll have a PlayerIcon script. The reason why we are making a separate script is because it can have extra functions like other icons. Basically, in this case, we can have like something like player orientation and such, and the rest of the map will be drawn on the basis of this icon only. All right. So firstly, we'll have a reference to Minimap script. Make it public. And that should help us with the multiplier. Let's see if it's public or not. It's not. Can make a return function for that. We'll need to have reference to the player object. So we'll go game object, player object, and we'll go this dot. Now I'll rename the capsule to player icon and also drag the minimap script over here. Save and play to test. As you can see, the player is hovering, the player icon is hovering a little above the mesh of the minimap. So it seems like I didn't put the values correctly before. So to rectify it completely that the scale is proportional, what we can simply do is we can just go to the minimap, reset its position, and let's just multiply it until it basically is the same size of our full map. So okay, I think it's a little bit larger now. Let's reduce it to half, and I think, yeah, it's overlapping pretty well, except you can see that over there it's not correct. So over there I think we need a extra height, and as we remember it was 1000 and 600 for the height. So I think the 2x multiplier for the default xy coordinates is allowing us to put it at 500, but in the y-axis we need to put it at minus 600. Oh, that changed it evenly. Okay, minus 500 minus 600, and oh yeah, it shouldn't be over here, should be over here, I guess. Yeah. Oh yeah, so that's the correct proportion. Now we can scale it evenly in and out. Let's change it inside the Blender file as well. So this was minus 25, and this y-axis, no, we don't care about this. This is the z-axis, so this should be 30, and save this as well. Now if we revert, it should be proportionately correct. And now I think we can make it minus 500, and it should, yeah, it is revert. As you can see, now our player is much closer to the actual position than previously. It's not 100% accurate currently as well, partly because of the fact the player's position is actually half a meter lower. Our player icon's position is half a meter lower. We'll need to fix that as well. So let's go to our player icon. We'll basically remove the capsule collider, mesh filter, and mesh render, and give it a child object which will be called as capsule. And then let's enter, raise it by 0.5. Okay, now we need to raise it by 1, and done. Okay, let's now create the shader. So we'll go to assets, create folder, shader. We'll call it create shader, Shadergraph URP, and lit Shadergraph. We'll call it map shader. Now let's go to a material, create the material, call it map material. We'll drag the map material to our map, and then choose Shadergraph and map shader. Currently map shader is not doing anything, but yeah, we'll make it do something. Let's open up the map shader, and now this is it. We can make it full screen by shift plus space. Alright, now let's add our variables. We can add firstly a float, distance threshold, Then we can add player icon position. Okay, so now what we'll do is we'll drag this and then right click position, and then we'll get the distance. Okay, now we'll go to logic, logic, and in logic we'll go with comparison, and we'll set it to less or equal. So okay, I think I have to drag it to A, then distance threshold, and this. So if A is less or equal than the distance threshold, then this will be our predicate, which will be true. So I'll go to branch, and if it's true, we want the value to be 1, and it's false, we'll have the value 0. Let's move it a little bit over here, and when we select a fragment and go to our graph inspector, we can go to set graph settings, and then here we can change alpha clipping and enable it. Now we'll keep the threshold at 0.5, and now we'll plug this value to the alpha and save it. Now let's go to our scene. As you can see, our graph has disappeared, and that's because our material is basically making it disappear. It's still there, but if we select it and increase the distance threshold, it appears. You can set it to something like 10, and then set the player icon position to something like 5. Let's just set it to something like 1, 1, and 1. And reduce it to 2. Now what we need to do is in our PlayerIcon script, we can get a material reference. So we'll call it public material map material. In map material, we'll call the set float set vector function, and we'll have to copy the name of the property correctly. So this is not the name. We'll have to go to click this and then enable the graph inspector, and here the underscore reference, the one with underscore, is the correct name. So we'll copy this, then set the value to this dot transform dot position. Now if we drag the map material to over here and click play, we should have it that the map is drawing only where our player is. Okay. Now firstly, these icons are actually quite large, so what we can simply do is we can select the icons in their prefabs, and then we can just simply have a scale of 0.1, and that should basically do it for us. As you can see, the icon size is much better now. Now what we really need to do is basically disabling or hiding these icons whenever our player is not close to it. So currently our icons are showing despite the fact that player is not in range, but we don't want that. So there's multiple ways to do this. One is a simple distance check. That's the simplest way. Then there's chunks. Basically you have to divide these icons into chunks, like a chunk of 10 meter or something like that, and based on that chunk you can basically disable or enable it. Or of course the third way to do it, which is or in case of chunk, what you can also of course do is like the chunk can enable the close ones and disable all the faraway ones, but on the enabled ones it also checks exactly which one is in radius. So the chunks enable disable basically first happens on a chunk basis, and then on the enabled chunks it also checks whether it is inside the radius or not. So that will be the pseudocode for chunk based code, but like it's too much to implement right now. And the third option is to simply write a shader for that as well. I mean, even technically this shader can be copied and applied to it as well, but yeah, in that case we'll need to update the position value for all these as well. So currently I'll go with the simplest option, which is a simple distance check, and for that I'll open the minimap behavior minimap icon behavior script, and I'll handle it here only. So what we'll do is we'll basically have the player icon be passed as a variable in the initialize function itself. So we'll have a transform for player icon, then we'll have a transform underscore then over here what we'll need to do is we'll need to cache the player icon itself first. And so that should do it. Now we'll drag the player icon to our minimap terrain, and here we have the player icon. So now we can go around with the logic. We have minimap icon behavior, and get the sprite renderer. And serialize it. Save on runtime performance. we need to add a threshold as well. So instead of getting the threshold, instead of making a threshold here, we can just get it from the Minimap script as well. So we'll have a public load Minimap visibility units equals to, let's say, 5f, and we'll add this as well. If this is greater than this, then we'll use just the simple logic, or rather more complex logic. Type renderer.enabled equals to not this. Put a bracket. Okay, so not means, so if this is true, if distance is greater than the visibility threshold, then we need it to be not true, which is disabled. So if this is true, then we want the opposite, which is not true, and that will be set to the enabled factor. And this should basically do it. Now let's check the visibility. It's 5 here, and let's also check the, that said, we'll have to make sure that our values are consistent across the shader and the C# code. So I'll set it to 5 over here, and let's set it to 5 over here as well. Okay, so I think I should have done this in the beginning. We go to player armature and increase his speed to something like 40, speed to something like 25. Yeah, that should do it. Now we have an error. Oh yeah, we didn't assign the reference. Yeah, this seems to be pretty good. So our mesh doesn't have normal map and color, so I'll add that in a montage. So now our mesh looks pretty great, but I don't think I like the size anymore. I initially liked the size, but minimap dimensions are not looking good for me right now. So what we'll do is, first of all, open Blender and check the size. So I think we can at least divide by 10. So 2.5. This is much more in the manageable zone of what the minimap can be, because it's going to be basically like a small radial minimap on this side of the screen. So yeah, this might do it better. So we'll need to adjust the visibility units as well. So we'll change 5 to 0.5, and in the material as well, we'll, I think, first 5, and this is not enough, so we'll move to 0.5. That should basically now look like a mini map. I'll just adjust to see what it looks like. It looks good. Okay. Now the next step here will be to actually position it on the left side of the screen, following the player as a HUD. So to do that, we'll write a script called Minimap Follow. Here we'll have a target which we'll choose as our camera. So and then we'll offset. So it does not seem to be working correctly, but the code is actually kind of correct, but not 100%. So if you want to diagnose it, what we can do is we can just select this blue, like we can give this gizmo icon, and then we can set it to 000, and click play. And if we turn on gizmos, we can see that our map is just in our face. But if we increase the Z value, we can see that it's actually in the center only. But the problem is the map's origin is in the center, not necessarily the player's position. So if we like move quite far away, you can see that the map might start drifting because the origin is still correct, but the actual position is not. So what we'll need to do is that we'll need to offset this movement by adding the players, by inverting the player's local position. So let's get out of the play mode, and we'll need to find the player position. So I'll basically have a reference public transform player icon position, and then we'll okay, we'll need to rename this local position. And this should most probably fix it. No, actually it won't fix it. It's the opposite of what we needed to do. Oh no, it's correct. Ah, that's it. We haven't put the player icon. So make sure that our player has enough space to rotate. This should basically function well. That said, this current transformation method does lead to a little bit of lag. But as you can see, it is leading to a better size. We'll reduce the size of this little bit as well. 0.05, 0.02. Mm, maybe reduce the radius as well. We have our minimap terrain. We can reduce the radius to something like 0.25, and same in the material, map material 0.25. Seems good. So one more issue with the map currently that we have to tackle is the fact that if we move around and if we actually get near a geometry, we can basically clip the map inside the object. So it's not visible and it appears like a real 3D object rather than appearing as part of the HUD or part of the UI. So to make sure that it is visible at all times, we can do some changes. So we will switch to the shader, and then what we'll do, let's make it so that's inside the wall. Um, mm, 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 mm. Yep. Okay, that should do it. And now, to make it that it's visible all the time, firstly we'll set it to always, like depth test to always, and let's just save. And yeah, as you can see, it's visible, but as you can see, it's only visible from the front, and that's because our render face is set to front. So we should set it to both, because then we'll be able to see the map from both sides. And once we have set that, we can see the map um, from all the directions. So it's visible all the time. And yep. And the sprites themselves don't have any issue, but our player icon will have an issue. So for that, we'll need to basically have the player icon um, have a particular material as well, which is set up similarly. So I'll leave that up to you guys, because if you look here, it's getting overridden by that as well. But it's not really that hard to do as well. And here's a full implementation by me. As you can see, it can do a lot more stuff. We can have a full like map reveal style of thing where you move around and map gets revealed more and more. You can also save it to different file systems for a long game. And yeah, this other stuff. So if you feel like there needs to be a part 2 with these implementations, sure, uh, tell me.